Students, in this program we find the sum of two matrices. See, we have a notion of a matrix in mathematics. You must have read it in 11th or 12th. A matrix is a collection of numbers in the form of a grid, or say rows and columns, or rows and columns, and two matrices of the same size can be added to produce a third new matrix. So we are going to do that in this program. The purpose is this: write a program to add two matrices of same size and store the result in a third matrix. See, it is necessary for two matrices to be added, and they can only be added, they must be of the same size. That means the number of rows and number of columns in the two matrices must be same, then only they can be added. Look at this example. Suppose we have two matrices. Matrix A is given here and matrix B is given here. Okay, now see, we said a matrix is a collection of numbers in the form of rows and columns. So how do we represent such a collection in Python? Look closely that here we have written a matrix in the form of a nested list, or a two-dimensional list, a list in which the items are themselves lists. Okay, see, this is the list. Here the list begins, but the items in the list are not just numbers, these are the list themselves. Such a list is called a nested list. So what we do is that we can consider each inner list as a row in the matrix, and each number may be considered to be belonging to a different column in the matrix. Okay, see, we can what we mean by that is that if we consider this list A, if you look at this list A in the following sense, that you consider this to be a row 0, then row 1 and row 2, and these are considered the columns 0, column 1, column 2, column 3 and column 4, then you can represent a matrix using a list of lists. Okay, so this is what we mean by how we represent a matrix using a nested list. So similarly we have another list B, which has 3 rows and 5 columns. Okay, now if we were to add these two matrices, then if you must remember that adding two matrices is done such that items in the two lists at corresponding locations are added. Okay, the items in the same location are added. That means one from list A, here one from list A is added to 16 in list B, because they are at the same locations in the two matrices. So adding them gives us 17, which we put in the resulting matrix C at the same location. Similarly, when 2 is added to 17, which are at the corresponding locations in the two matrices, then we get 19, which we put at the corresponding location in matrix C. Similarly, when 15 is added to 30, then we get 45, which is put in the corresponding location in the matrix C. Okay, now as we said, we are representing the matrices in the form of lists of lists. So when we say 1, how do we access 1? We have to see, we know that a list, an item in a list can be accessed using indexes written inside square brackets with the name of the list. So we are now going to see how do we do it exactly. So you can pause here this video and consider for yourself how this problem can be solved. Now, before looking at the programs, we should see some points. We want to add the items at corresponding indexes in the two matrices. This is clear, as we have explained. Then the second point is how to access each number in the matrix. Now the problem arises, how do we access each number? How do we access say 1, and how do we access 16? How do we access 4, and how do we access 19? We want to access the items at the same indexes or same locations in the two nested lists, but how do we do it? The question is this. Okay, now you, as we have seen, we have inner list put in an outer list. Okay, so we, to access every number in the list A or in the list B, we actually need two indexes. Okay, so this is very natural to see that since list A is a nested list, the first index will give us the inner list, one of the inner lists. Okay, and the second index is going to give us one of the numbers in that inner list. Okay, this part gives one of the inner list, and this part gives one of the numbers from the inner list, right? Okay, see, as explained here, we need two indexes. First index tells the index of the inner list, which of the inner list we need, that is specified by the first index, and the second index tells the index of the number within the inner list. Okay, so we mean to say that first index will give us one of these three inner lists, and the second index will give us one of the five numbers stored in the inner list. All right, that is how we are able to access all the 15 elements from A or B. All right, so that is what has been said here. First index tells the index of the inner list in the outer list, and the second index tells the index of the number within the inner list. Since these are meant to be matrices, okay, A and B are considered as matrices, and matrices have rows and columns, we can name the first index as row and second index as a column. Okay, that means we are using the first two indexes. We can name this first index as row. Okay, so row may be 0, 1 or 2, and we can name these 5 indexes as column, which may be 0, 1, 2, 3 or 4. Okay, so there are 3 rows and 5 columns. Okay, so remember that we are referring to the first index as the row and index, and the second index as the col or column index. Col is just short for column. Now consider how exactly this works. To understand this, we consider what is referred to by when we write A square bracket 1 square bracket 3. As we said, we are having two indexes here. First is 1, second is 3. All right. So now let us see which number does this expression exactly refers to in the list A. Okay, as we explained, the first index, now as we said, the first index we will call it as the row index, and the second index 3 we will call it the column index. Now the first index, the row index, gives the inner list. It gives the inner list row, that is row 1. See, these are the row indexes. This is row 0, row 1, row 2 for inner lists. Okay, so when we say row 1, then we get the inner list, this inner list we get. And then when the second index, the column index, gives us the column 2. The column, actually it's not 2, it's 3. Column 3 it's obtained here. I should correct it. It's column 3. Okay, so what happen? So when we see, so what we see here, we are referring to the inner list at index 1, and within that inner list the number at index 3. Okay, so what we get, A square bracket 1 square bracket 3 is this list, and inside this list the number at column index 3, which is 9. So we get this 9 when we write this A 1 3 or a square bracket 1 square bracket 3, we refer to 9. We refer to this item in the list. Okay, this is how the two indexes work. Similarly, we can again consider b, which item does the expression b square bracket 1 square bracket 3 refers to. Okay, again the index 1 is the row index and index 3 is the column index. This is the row index and this is the column index. Okay, and when we look at the list B as a matrix, then here is the row with index 1. This line, this list is the, this inner list is represents the row 1, and inside this the index 3 represents this number 24. So what we get is, by in row 1 at column 3 we get the number 24. Okay, so this expression b13 refers to 24. Similarly, other indexes work. Okay, in the same way other indexes will be working. For another example, you can say a 2 2. You may ask which number. Okay, that is to say, you may ask which item does this expression a22 refers to. Okay, so now see, the first index 2 refers to the row index, so we are talking about row 2, this list, and inside this list we want the column number 2. The second index refers to the column number, so column number 2 happens to be this number 13. Okay, so at index this is 11 at 0, 12 at 1 and 13 is at 2. So we get, when we write a22 we get 13. Okay, so remember this, how these two indexes work. Now what we do is, now that we know how the indexes refer to the items in the two nested lists A and B, now we see how do we add them. For this we first, as we discussed, we first create a new matrix C, which has the same items as A. These are just useless initial values which will be replaced in step 2, next step. That means actually I should make it step 5 here. This is step 5. Now what we do with this, how do we add the two items in the matrices? Now the step 5 says that we then run a for loop with a loop variable named row. Look closely at this loop variable, it is named row, for index values 0 to 2. Okay, because our matrices 1 A and B both have 3 rows, that means indexes 0 1 and 2, so we need to run a loop with values 0 to 2, and we name that loop variable row because it represents the row of the matrix. In the loop, and when we are in the loop, writing a square bracket row or b square bracket row will give us the inner list at first index row in A and B respectively. As we have seen, whatever is the value of row, that index, the inner list we will be able to access in A or B. If the value of row is 1, then we'll be able to access this inner list of A and this inner list of B. If the value of row is 0, then we will be able to access this inner list and of A and this inner list of B. Next, what we do inside this for loop with loop variable row. Okay, we need to run another loop inside the loop at step 5. We need to run another loop inside the for loop just discussed. Okay, we run another loop for column index 0 to 4, because as we see we have 5 columns in A and B, and the index numbers range from 0 to 4 for columns. Okay, so we run another loop with values 0 to 4. Now when we write a row call or B row call, this will give us the numbers at index column, which will this will give us the numbers at index column in the inner list A row and B row respectively. As we have seen, writing A row gives one of the inner lists, and writing A row call gives one of the numbers in that inner list. Similarly for B row call. Now what we do with these two, which numbers from A and B, we can add them and assign the result of this addition to the matrix C by writing C row call. Okay, we will be able to put this result of addition into matrix C with the same indexes, because the result of addition has to go at the same location as the two items added. Now we look at the program. See, this is the program. This is the same list A, matrix A, and this is the same matrix B which we have seen. Okay, now we need a list or matrix of the same size as A and B. Okay, this we do in this list comprehension. See, this statement may look something new for you, but try to understand what it is. Okay, look closely at it. It is using the list function. First of all, you can notice the small brackets. So we are using the list function, and inside this we are writing square brackets. So that means we are providing a list to this list function. Now what is the list? The list is no items are listed in this inner list. Okay, actually we have just written list. Again we have used the list function here, list of x for x in A. So what this effectively means is that it takes each inner list from A, prepares a new list from its items, and puts in list C. So this way list C gets three inner list with the items same as list A. Okay, if you don't understand this line completely, don't worry, it will not interfere with our objective of understanding the indexes and for loop with the list A and B and addition of these matrices. Now what we do next is we find the how many rows are in A and B. We just find length of A. Okay, see, now this is interesting. When we find length of A, it tells us how many inner lists are there. So it will not tell us how many elements are there in each inner list. It will not tell us that. It will just tell us how many inner lists are there. So there are 3 inner lists. So length of A is going to give us 3 here. So row size will get value 3. And but to know how many columns are in each list of A, we have to find the length of one of the inner lists of A. Okay, so we just take A0 refers to this inner list, and we find its length. Okay, now we get 5, because length of A0 gives us 5, because there are 5 numbers in this inner list A0. Okay, now 5 gets assigned to column size. So now we know both the row numbers and column numbers of A and B. Remember, A and B are exactly same size, the same number of rows and same number of columns are there in both A and B. Now we come to the loop. See, this is the outer loop which we discussed. It will handle the row numbers, and the inner loop will handle the column numbers. So outer loop says for row in range 0 to row size. Okay, now as you remember, row size will be 3. So what values will the row loop variable row getting is 0, 1 and 2, because 3 is the stopping argument. Okay, so we are going to get values 0, 1 and 2 in the loop argument row. Okay, and what we do inside this loop is just run another loop. All right, see, it is important to understand here that how many times this inner loop will execute, it will be executed. It is the actually it is treated as a statement in the outer loop. And what outer loop does is to execute the inner statement some number of times. How many number of times? We have seen it will run 3 times. So this inner loop will be run 3 times. Now we come to the inner loop. We look at the inner loop. The inner loop says for call in range 0 to call size. Now we saw that call size has the value 5, and which is applied as a stopping value to range function. So what we get in the loop variable column is values 0, 1, 2, 3 and 4. These 5 values will be assigned to the loop variable column. Okay, and now look at the statement which is inside this inner loop. Okay, look closely. We have only one statement inside this inner loop. Okay, so can you tell how many times this inner statement will actually be executed? See, any statement inside this outer loop will be executed 3 times. Okay, so what is the statement inside this inner loop? It is the inner for loop which is inside this outer loop. So this inner for loop will be executed 3 times. And since this inner for loop gives 5 values to the loop variable call, that means the statement in the inner for loop will be executed 5 times. Okay, so total number of times this in statement of inner for loop will be executed is 3 multiplied by 5 is equal to 15 times, because for 5 values of loop variable call this statement will be executed, and the the inner loop itself will be executed for 3 values of outer loop variable raw. So total number of times the inner loop statement this statement, this one will be executed is 15. All right, so and that is exactly want, because if you look at the matrices A and B, how many elements, total elements do you have? You have 3 lists, each having 5 numbers. Okay, so we have 3 into 5, 15 numbers in both lists A and B, and you want to add corresponding elements, each of these 15 corresponding elements you want to add from A and B. Okay, so this loop, the two loops combined will process all the 15 elements of A and B. So now we look at the statement inside this these two for loops. Now what is the statement? It says C row call. That means it will be referring to the column index of the inner list of C with the list index row. Okay, now what this C item getting? It is getting the sum of A row call and B row call, and we have already seen how A row call and B row call work. We have extensively discussed it. So you know that A row call and B row call actually give the same items at same indexes in the two matrices A and B, and the result is being put in the identical location in matrix C. Okay, so this is how this addition of two matrices is done, right? Now when you when you are done with these four loops, what you get is the matrix C as a sum of two matrices A and B, and which you output using two print statement. First you print the sum of two matrices, then you print the matrix C, and that's how you get the result of addition of two matrices A and B. Okay, once again you may try to see that the outer for loop runs on the rows of A and B. Okay, row 0, this is row 0, this is row 1, and this is row 2. So outer for loop accesses these 3 rows of A and B, and the inner for loop accesses the 5 columns of each of A and B. Each of matrices A and B's 5 columns are accessed using the inner for loop, and the outer for loop accesses the 3 rows of matrices A and B. So that is how we accomplish the addition of two matrices. Thank you.